Number 6. Find the domain of the function f of x is equal to the square root of x plus 1 divided by x squared minus 4. Okay, so since the domain is the set of all possible x values, to find it we have to consider the restrictions on x. So let's start by noting that the domain of the polynomial x squared is equal to all real numbers. And that's for any polynomial. It could be x squared, it can be x, it can be x minus 1. The domain is all real numbers because x can be any real value. Now for the expression 1 over x, the domain is all real numbers except for 0. Because if we have a rational function and the denominator is equal to 0, the function is undefined. Now for the square root of x, the domain is all real non-negative numbers. X must be greater than or equal to 0 because we cannot have a negative number in the radicand of a square root. Okay, so for our function, we see that it's a rational function. So let's start by noting that the denominator cannot be equal to 0. But we also see that we have a square root in the numerator. So we can state that the radicand of that square root must be greater than or equal to 0. Now to determine our domain, we can solve these expressions for x. Now to solve this first expression, we have to factor it first. So we know that x squared minus 4 is going to be the product of x plus 2 and x minus 2. And then we'll just solve for x. We'll solve for the x in each of those binomials. So x plus 2 cannot be equal to 0, which means it cannot be equal to negative 2. Now I'll write that in a different color. And x minus 2 cannot be equal to 0. It means x cannot be equal to positive 2. Okay, so for x plus 1 must be greater than or equal to 0. This is a linear expression, so we know that when x plus 1 is greater than or equal to 0, x is greater than or equal to negative 1. Okay, now that we know the restrictions on x, to state the domain in interval notation, it helps to graph those two expressions on a real number line that goes from negative infinity to infinity. So to graph the first two expressions, x cannot be equal to negative 2 and x cannot be equal to 2. We just plot those two numbers with open circles because they cannot be included in our domain. And for this other expression, x must be greater than or equal to negative 1. We just plot negative 1, but this time it must be plotted with a closed circle because it can be included. And then we shade everything greater than negative 1, except 2, of course, because we've already established that that cannot be included. So from there we see that our domain lies on the interval from negative 1. Negative 1 has a closed bracket to 2. And then from 2 to infinity.